I am Ramzi Khsib. I'm a principal software engineer with the AWS Elemental. I've been with AWS Elemental for over 6 years, and I've been working on video compression for the last 18 years. I mainly focus on video quality, any video compression algorithms out there, and my job is to make picture look good. I spend my day looking at video in a silent form, always on mute, and I know every person on CrowdRun probably by nickname.
That's great. I love it. Ramzi, welcome to Inside the VideoVerse. Um, only a true codec engineer can say that I watch video 8 hours a day with no audio. People say, "What are you talking about?" Must be such a boring job.
The
Oh,
interesting
wow.
part is you catch yourself at night after work watching video without audio, and that is wonderful. Like you cannot try read on the lips. I guess it's our tray. Any video compression will have this.
That's right. Yeah, that's right. Wow. Well, that's great. Well, really, really awesome to have you on the show. Thank you for coming on. And, when we were discussing what to talk about, I think immediately you said, let's talk about AI, machine learning. And it's, of course, a super hot topic. In any industry now, but especially in video compression. Let's start just with a general, maybe a general, almost like an explanation. One of the things I do find is that, we just had NAB, for example, and you walk down the aisles on the show floor, and there isn't a booth, regardless of what they sell or what they do, that doesn't have AI or ML or something related to that as a feature of their product. So I think a good place to start is, what is the difference when you hear artificial intelligence, machine learning, deep learning? Define it for us in the context of video compression.
Sounds good. I think I will start by AI because that's the broader term. And AI in general and definition might vary. Is a term used to classify that machines that try to mimic human behavior, meaning learning or simulating any human task. So AI is like the umbrella term for anything that machine will take over and do any human task. Under the AI, there is the machine learning, and machine learning is a subset of AI. And what machine learning does is we try to learn from past data, and it uses massive data. It uses training, it uses learning, and the objective is to predict the future or to make decision. A smaller subset inside the machine learning is deep learning, and machine learning has been around for decades. It's not something new. What is new is deep learning, and deep learning is tightly coupled with the idea of neural networks. So, with the advent of neural networks and the AlexNet in 2012, where it did show a great achievement by neural networks. Now, deep neural networks are the kind of the hype of the moment. So, people try to, or use the words deep learning, machine learning, AI interchangeably. I think we are in machine learning phase. I think AI is probably far out a couple of decades, but I think we are in the era of machine learning.
Yeah. There's a lot of really great scientific and academic work being done, especially in the area of video compression and uh, with machine learning, deep learning, AI, as you've outlined. there is no silver bullet. I think you actually said there is no free lunch. So I would love, for us to spend some time talking about how, let's start here. How does one separate, I'll call it the hype from the reality, but what I really mean by hype is like the academic research, which is a little bit hype because often it really can't be deployed commercially for any number of reasons. It can just be it requires way too much compute than is feasible. Maybe the bang for the buck is actually not there. So, for what it costs, to actually execute the algorithms, there's other ways, other more efficient ways to get there, even though it may be less sexy. Um, but let's start there. What do you think about when you look at this and separating kind of that hype from the reality of what can be used in commercial use?
I think you hit the quite essential point in video compression and machine learning and the hype around machine learning. What video? I'll focus my answer on video compression because audio is different. NLP, natural language processing, is different, and typically video is the kind of the trailing industry. It usually starts with image, and then you see the repercussion or the fruits of that research in video. In video, we typically use models, like we use thresholds, we use heuristics, we use these models, and these models have been around for quite some time. The problem with these models is they are not adaptable, and video covers a wide spectrum of use cases. And with the COVID, the spectrum got even more exponential, and you have all formats, all resolutions, and even vertical video. Who would believe that vertical video is a thing?
Yeah,
Apparently, it is today.
that's
Uh,
right.
so machine learning came in the adaptability, making these models we use in video compression, make these thresholds, these heuristics adapt to content, adapt to scenarios, adapt to use cases. The problem with machine learning, and you stated that problem, is compute. The deep learning coupled with video compression, especially video, if you want to do real time processing, deep neural network is expensive, both
Mm-hmm.
on memory, on CPU or a companion GPU or any hardware. So typically, right now, it's hard to see these deep neural networks and applied to video compression. So then that's the hype at the moment. It might change in a few years. It might change with the new hardware, with quantization of the neural network. But what's happening today, what we have today, the reality today is we're using machine learning. We're using classical, I would say, machine learning, and things like VMAF. VMAF is built upon machine learning.
Yeah.
A lot of non-reference metrics are built upon machine learning, and those are running real time. So the difference, the hype resides in, is it in production, or
Mm-hmm.
is still in research and academia. And I think
Mm-hmm.
that's the fine line between what we think is usable as of today, because I'm pretty sure things will evolve in the direction of wider use.
Yeah, those are great points. One of the questions that I have, and I'm sure our audience does as well, is it really just an issue of compute needs to catch up to a point that these algorithms can be run fast enough or efficiently enough. In other words, are we just waiting for faster processors, more cores, or is there something else that needs to happen? Like, can you explain that a little bit more about what we're really waiting for to be able to
Mhm.
cross over from, like we said, hype or academia to actual real world use, viable real world use?
I can think of two examples. I will take the example of deep uh, or deep or deep learning based video compression. So this system is end to end. So you encode, so you use machine deep neural network from end to end. The the idea is quite simple. Is we're gonna replace the entire video compression pipeline with these compute intensive machine deep neural networks. And the question is, you have two dimension, or probably actually they have three dimension. You have the compression efficiency, and you have the your rate distortion typical, and you have the
Mhm.
compute. So
Mhm.
for a deep learning based video compression, you have to beat in terms of compression efficiency what we have as classic non-machine learning or partial machine learning methods. So
Mhm.
you expect machine learning based codec to beat the VVC, the AV1. That's the first target, and you have to beat those codecs by a reasonable margin to
Mhm.
justify the compute. If you are at par or below, or probably a couple of percent better, I don't think it's
Yeah.
viable.
Yeah.
That's one aspect. So you have, in terms of BD rate, we love to call BD rate. I think the we always have this discussion with my peers is for a deep learning based video codec, how much BD rate you expect that to sell it.
Mhm. Mhm.
We typically see in from generation to generation of codec, like we love to say, oh, 50% or
Yeah.
33%,
Yeah.
and there is a debate around that. So I think
Sure.
machine learning based codec has to uh, deliver the 33 to
Yeah.
50% BD rate improvement.
Yeah. Yeah, it's super interesting. In as you're working with your colleagues, especially those who are really spending time in the scientific community and academic, do you think, or are you finding that they really factor in at all how deployable what they're building is, or do they just sort of are they, I don't want to say stuck in, because I'm not saying in a derogatory way,
Mhm.
but let's face it, when you're doing research, you're of a very different mindset. You work for AWS Elemental. You operate, or at least the platform operates, video encoding for some of the largest services in the world, right? Obviously there's things you would love to do as a video coding practitioner that you can't, because they're not feasible for the reasons you just stated. Do you think the scientific community, the academic community, gets that, or are they coming around to that, or are they still sort of stuck in theory?
I think there are two paths of research. So unfortunately, the academic research is completely decoupled from the reality of a production deployable.
Mm.
And one of the things I think we tend always to forget is we always factor the compute cost, the hardware cost, but we kind of forget the training cost. It does cost money.
Mm.
So that is always, and I always like go to the CVPR challenges, like the click challenge, the
Yeah.
tier challenge, and nothing like in the training is factored in. So you have this beautiful model if it took
Sure.
2 years to it
Yeah.
took 2 years to
To train
train,
it.
I think I personally and my peers wouldn't wait 2 years to.
No.
I'm kind of exaggerating,
Yeah.
just to make a point.
But your point stands though. Yeah, exactly.
And that's the I think that research is completely decoupled. The other research areas I'm seeing and where more reasonable effort is the effort done by in AV2 and in
Mm.
JVET
Mm.
and in VC,
Hmm.
and they try to incorporate machine learning techniques in the standardization process.
Hmm.
As of today, I think there are a couple of trials on JVET. JVET has more mileage.
Hmm.
AV2 is catching up. They formed a focus group number 4, and the discussion always turns to the point. There are a couple of questions, and I think these questions are essential: is what to standardize, how to use it, how much compute, and what benefit, like what percentage and bid rate it has to bring.
Mm.
Um, I think in one of the meetings there was this statement from a fella from Google. I didn't catch his name, and they found out that like a small neural network like mobile net V1 around
Hmm.
with 2 million parameters. This is fairly small for
Hmm.
this is nothing compared with the typical large.
Sure.
Um, it would take more silicon area than an entire AV1 hardware decoder. Like this is the basic unit.
Yeah.
In terms like I would like to put like if you do some classification,
Sure.
mobile net V1 will get you 70%, 75%, and that will be equivalent in terms of silicon
Mm.
to AV1. That is the
Mm.
struggle, and that is the limitation and of deep neural network being
Yeah.
used in. On the other hand, there are, like I said earlier, you can still use machine learning in
Hmm.
even in real time. The way VMAF, non-reference metric, use machine learning is, I think, is the first step to incorporate machine learning in video compression. It's I think deep neural network will come to video compression one day,
Hmm.
but right now it's hard to I think it's hard to justify. And the results, like the just to put again numbers, JVET in they did a meeting in last month, and they found out that with some of the tools would get 11%, and I think that's still too little for the compute.
Yeah. 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 Not enough bang for the buck, you know. I want to talk about VMAF, but we'll circle back around to it. One of the ideas that I have, I was going to say theories, but it's not a theory, but is that we're marching on this cadence of every well, it used to be 10 years that a new video standard would be released. So you think about MPEG 2, and then H.264 2003, and then 2013 HEVC, and actually it compressed a little bit with VVC. um, but with each new standard is like a 10x or 20x of complexity. And obviously, those that are optimizing the codecs, are getting to work very fast. I mean, you look at how quickly AV1 went from being, a laughing stock, like a minute a frame, to now actually in some settings as fast as X264. And still with bitrate savings, so still with the benefits of the codec standard. So this is improving. But my question to you is, one of the ideas that I have is that at what point do we need to shift our innovation from developing the next standard to developing more efficient machine learning models and advancing deep neural networks to get that increased efficiency from the existing standards. And the obvious advantage that because I live largely in the world of, largely exclusively, I'm working with companies and around platforms and services that are delivering content to millions and tens of millions, and in some cases, hundreds of millions of users. And so you always have to think about, how big is my playback ecosystem? Do my customers have devices that can even support this, this new format, this new standard? And it seems to me that we're at a place now where, now HEVC is becoming almost ubiquitous, very quickly anyway, and especially with the upgrade cycles of at least in North America and I think Europe and many parts of the world, people are on a current generation iPhone or maybe just a 1 or 2 old generation, which all support HEVC. Do we really need to move, to VVC or some other standard? Or should we be investing, just as an example, in more efficient ways to, to squeeze bits out of HEVC? And this is my question to you. And I'm wondering if you have thoughts on this, if you've thought about this very same thing, because it has the advantage that if I use machine learning, it still is an HEVC compliant bit stream. It's just 30% smaller, or some percent smaller.
I think that relates to the effort that I, with my team, spent for the last 3 years. And one of the questions we always had is how to use machine learning as a powerful tool, and also trying to solve problems that our customers are facing. And the question is, should we move to a new codec, or should we stay on the same codec? I'll answer it like this. There are features in any codec that you have to build. You have to build rate control. No matter you have
right.
MPEG-2, VVC, you have to build rate control. Yeah. So if your rate control is not accurate, is not robust, I think it's not ready for the real world. It's not ready for prime time. So instead of thinking about, there are building blocks inside the encoder, no matter what codec. It has to be or could be codec agnostic. So what I did in 3 years ago is we have rate control, and instead of having versions of rate control for MPEG-2, for VVC, HEVC, you name it, let's unify it. Let's use this powerful tool that can predict in the future. And it was not free lunch, trust me. It took months trying to figure out. Right. But there are a lot of lessons learned there. So I think one of the lessons learned in this effort, first of all, knowledge in the machine learning. You have to understand how these models work. You have to understand. That is the first lesson. Second lesson is design. Driving a sports car does not make you a great driver. You have to learn how to drive. Yeah. So that's the second lesson. And I think when you keep in mind that this model has to run real time, it's part of the design. It's not a requirement ad hoc. Yeah. So to answer your question, I think having a new codec is great. It probably is future-proofing our industry. But we have questions, even with MPEG-2, we have questions of rate control, ABR, a lot of interesting question, motion search, adaptive quantization, perceptual optimization. All these themes could leverage from machine learning, and I think it has to be, the effort of research has to go in parallel with the future codec. Future codec, I think it's essential that we might need, like we needed the HEVC when we moved to HDR and 4K. We might need the AV2 in 5, 10 years. So, but at this point, people are watching Super Bowl, so people want to watch Super Bowl in 4K, and we need to solve that. And nobody will wait, or like the streaming when the quality drops.
Yeah.
Uh, Nobody likes that. So we need to
Yeah.
solve these problems. And like I said, some components are codec agnostic, and
Yeah.
you have to address that no matter how advanced the codec is.
Yeah. Interesting. And you touch on this, but I think it's worth even highlighting a bit further. Is that the answer? This is my most favorite. Anyone who knows me knows that it's a little bit of a joking statement, but it's very true. Whenever a video practitioner is asked a question, the answer always is safe to say, it depends. What are you trying to do? you know, so the point though here in all seriousness is that what you point out is that there is an application element. So are we talking about a live encoding workflow? Is this just earlier today, I interviewed someone and we were talking only about WebRTC, about RTC applications. And we were talking specifically about how the way that you think about optimizing an encoder and making coding optimization decisions in RTC is very different than for VOD. So that's one of the points to highlight there. Now, Elemental, I believe in all of your encoders, supports a QBR function, right? Which is sort of a content adaptive. It's QBR. Is that the
QVBR.
QVBR? That's right, QVBR. So, can you comment? Are you using machine learning in QVBR? And can you give any insights into how that system works?
Sounds good. So the idea of QVBR is y- we identified cases that our old rate control was wasting bits.
Mm,
That's so. And the other hand, we identified that not all content are equal perceptually,
hmm
and not all content need all those bits, and not some of the contents are not getting enough bits.
hmm
And it comes down to predicting the perceptual value or the perceptual importance of that segment or video or group of frames. So at the heart
hmm
of it, it's a rate control function. And what's
Mm,
different from QVBR to CBR to VBR is what are the constraints, but the
hmm
modeling inside it is still QP uh, versus bits, and
hmm
that is based on rate control. And
hmm
based on rate control, so that's predictive function, and with a feedback loop and all of that. So we did apply a lot of machine learning and in the inside our rate control. So what machine learning brings into the rate control world is the highly adaptability to all scenarios, all contents. So what changed from one function to another is retraining with the new scenario. So
mm.
that is what we applied in the QVBR. But of course, there are some secret sauces in there,
Sure.
but the global idea is the perceptually not all content is the same, and you have to adapt to content. And this is in the trend of content adaptivity. I think
hmm
Elemental is not the only one, and we won an Emmy actually for this, and with many other fellows. And I'm so happy to see my fellow video compression artist win the same Emmy. And the idea
Yeah,
is,
it's
like I said,
awesome.
is you have to adapt to content, and it's a function where you take the perceptual importance and you have to
Yeah.
determine the number of bits. And
So now, did you create a new quality metric, or how exactly are you? Because presumably you're controlling the QP at what, the frame level, I guess, or maybe it adjusts. But you need some way to measure quality so that you're not introducing artifacts or leaving bits on the table. So,
Hmm.
what's the
I think
mechanism there?
I think the quality, in definition of quality, that you can define quality is the point where you start seeing artifacts.
Mm-hmm.
You can define quality. So be, and I like to like always this example. If you have an SD content like a PAL or an NTSC, and you code it MPEG-2 and you give it 18 meg, you
Yeah.
wouldn't see the difference if with the AVC at 5 meg, it will look the same.
Yeah.
So the the
Yeah.
the,
That's
the
right.
the key point is defining where the just noticeable
Mm-hmm.
difference or distortion, and I think that is the key definition in what we do. So we tune the model um, in a sense to define what is the viable QP for that particular content, and yet
Mm.
our adaptivity and I think we went down to the coefficient level.
Yeah.
So we do it on a scene base, group of frame or GOP base, frame
Yeah.
level base, block base, and we go even to the coefficient level,
Mm-hmm. Interesting.
because we think even within the same frame, the content is not the same. I mean, the
Sure.
perceptual importance. Like right now, we're talking. I think the salient part is we are talking the background. You can steal some bits from here.
Yeah. Yeah.
So we applied those. We applied those concepts into the QVBR.
Yeah. Awesome. Yeah, that's super interesting. And I said earlier I wanted to talk about VMAF because you specifically pointed out that VMAF is a machine learning based quality metric. And so I'd love for you to talk just a little bit more about that. I'm quite certain that all of our listeners are familiar with VMAF and even use it. But maybe you can share a little bit more about what's really going on under the hood, because I wouldn't assume that everyone knows that. So, what can you tell us about how
So the
VMAF actually works?
mhm. The idea of VMAF, I think, is you want to fuse or use different metric that model um, different ways to measure quality.
Mm-hmm.
As an example, for instance, PSNR is an excellent metric to measure fidelity of the signal, but has no perceptual value or importance baked into a PSNR. So
That's
what
right.
VMAF tries to do is tries to give some weight to different metrics depending on content. As an example, um, if you have a highly textured video, I think PSNR will drop quite a bit, and PSNR will not be reliable. So you will mostly give weights to another metric, SSIM or
Mm-hmm.
VIF. So the trick of and the genius part of VMAF is, depending on the content, you give different weights to the metric, and the training was done based on a human observer given
Mm-hmm.
a mask or so. So that's VMAF. So and the model would try to determine for each frame the weight of each metric. And it is what is interesting in VMAF, its simplicity that uses under the hood these metrics. Again, it's also its shortcoming. So
Mm.
because it's the weighted average of these metrics. So if these metrics are not um, quite reliable enough, So VMAF, there will be the weighted average of that.
Hmm. Interesting. Wow. Uh, so, are robots taking over? you know, so I have to tell you. So Dror Gill, who's the CTO of Beamer, he jokes all the time, that we're heading into a world where, robots are going to be creating our video and robots are going to be watching the video so the humans can go out and play, can go out and enjoy the sunshine. So anyway, it's a fun joke, but no, I think this is a really good way to wrap up our conversation is, well, what's the future for machine learning? I think we all can agree that, we are a long ways away from these purely machine learning AI based codecs. And I know there's some, I'm aware of a couple projects that are really groundbreaking and very academically stimulating. But when you look at the real practical requirements for deployment, they're a long ways away. They're not coming anytime soon. But I'm curious from your perspective, and especially as a very large commercial vendor, very important encoding supplier, to the industry. What's the time horizon? What do you see in the future? What's coming soon, and what's still like 10 years out or longer?
So robots are not taking over. This is my personal
That's
view.
good news, in my opinion, my humble opinion.
I will quote and I kind of segue to my answer. I'll quote Michael I. Jordan, not the basketball player, the
Yes.
machine learning scientist. The revolution of machine learning hasn't happened yet. So it will happen, but not yet. So like I said, video is kind of the trailing industry compared to image. So what I think we will see in the future and is more use of machine learning, but more focus on the perceptual aspect. The vision aspect, the coding tools, I think with VVC, AV1 or HEVC, I think we have a solid codecs. What's missing there is how to tune those codec perceptually. What I mean perceptually is if you have film grain, if you have graphics, if you have sport content versus, I think there is room there. And we in Elemental, I'm pretty sure everybody in the industry is seeing there is potential there. So the perceptual element is still missing, or probably missing is probably is there, but there is a large room for improvement. So I think machine learning will shine in that area. I think 10 years, or probably 5 to 10 years, the deep learning-based codec will start to re-emerge when they solve the practical aspects like standardization. What do you send the network? How do you compress the network? And one key, and I shout out to the research community, quantization parameter is the key parameter in any video codec. Start with that. Start with the QP, and I think that those two letters are the letters I used most in my last 18 years. So I think research machine learning has to start with those two parameters, 2 letters. Sorry.
Yeah. I couldn't agree more, and I think that's just an awesome way to end. So wrap up this episode. Well, Ramzi, thank you so much for sharing. This was really, we covered a lot in 30 or 35 minutes here. So maybe this is one of those that listeners will have to listen twice to, one of those episodes, but that'll be great. We'll have you back for sure. And, maybe we'll do a part 2, or we'll find some other interesting element to talk about, around video compression, video encoding. It's a very fun topic. So, thank you again for coming on the VideoVerse.
Thank you, Mark. It was a pleasure. Thank you, Mark.